This is the story of a person, and that's me, that did this problem and got it completely wrong, knowing that the couple shown acts in a vertical plane determine the stress at point B. So I'm going to do it again now, and I'm going to see what I did wrong. So if you look at this, you know, the moment is happening here, and they're telling you what the moment is. So that's good. So you know that the moment about the z-axis is equal to 200 counterclockwise, 200 kip times inches, right? So, for example, based on how this is shown, this shouldn't be here. The x-axis should be here, so that our moment is positive clockwise. So that's a little thing there. Now that we have that, we can say that we need the distance of the point B. And so this is a symmetric cross section, and the white part is empty. So we know that it's going to be halfway here and halfway there. So halfway along this direction and halfway along that direction. So what I'm going to do is I'm going to look at this, and this says that direction has a length of 4 inches, so half of that is 2 inches. And I don't even care about this direction because I'm trying to find a distance B from this z-axis, which is this one right here. And that's because we're looking at the cross section like this. So this axis, which is the z-axis, which actually points into the page, that is this axis right here. So this is my z-axis. So that's what we care about. Let me take all of this away and this out. So now what are we going to do? Well, we're going to look at this distance total and divide it by 2. So that's going to be 4 and 1 and 1. So that's 6 divided by 2. So that's going to be 3 inches. And now that we have that, I can say that my distance B from the z-axis, so that's going to be along the y, which I'm going to write here. I'm going to say that my YB is negative 3 inches. All right. So now that I have this, what am I going to do? Now that I have this, I'm going to find I total, or just I around the z-axis, which is going to be, so this is the part that's a little nuanced. So you look at the cross section. Let me just, I don't want to, if you look at the cross sections, you're going to have a small and a larger one, but they're all lying on the same centroid. And the inner part is basically a negative area. So what you can do is you can say 112 times whatever this dimension is, which we said is 4, times 4 inches times this dimension. Remember, this is the axis along which we're rotating. So the vertical dimension is the one that we are cubing. And so that's going to be 4, 5, 6 inches cubed. And then we're going to subtract 112 times the inner dimension. So that's a 2 and a 4. So 2 inches and a 4. I want to make this neat. 4 inches cubed. And so once we do that, what do we get? Well, we put everything into the calculator. It's going to be 1 over 12. We can even factor that out, but I'm not going to, just because I don't want to make algebra mistakes. So 6 to the third minus 1 over 12 times 2 times 4 to the third, and that's going to be 61.3. So this is going to be 61.3 inches to the fourth, right? So now that we have that, this is where I made the mistake. See, I got the -3, but I made the mistake there. So What I'm going to do now is I'm going to say that my S at B is going to be equal to minus mzyb over iz, which is equal to 200 kip times inches multiplied by negative 3 inches. There's a negative in front, remember, 61.3 inches to the fourth. And so 200 times negative 3 divided by 61.3, what is this? That's going to be negative 9.79. And it's going to be KSI. So I did it wrong the first time, but I got it right the second time. And I think that's all that matters, right? All right. I'll see you next time.